Okay, we're now going to talk about vector fields. We'll call the first vector field, we'll call it F, and it's where each point in a region has a vector associated with it. So the domain is a subset of the reals with what nth dimension, whatever dimension you're in, and the range is a subset of the vectors, whatever, however many entries you have, n. So a velocity vector field describes motion and the speed is the length of the arrow or the length of the vector. So if you think about a wheel, for an example, a turning wheel, you have vectors from each point associated with it as the wheel spins and turns to the right or clockwise. Or water through a pipe, motion. Or blood through an artery, any kind of motion you can represent as vectors. If the vectors are independent of time, it's called a steady state vector field. That means time doesn't matter. All right, so let, in this problem, x, y, z be a point. Then f of x, y, z can be represented like this as a vector. So I'm taking a point, I'm taking the point x, y, z, and I'm taking it into a vector. So this looks like x, y, z is going into the vector f, g, h of that point x, y, z. So this function determines a vector field. Okay, for the first example of a vector field, let's take f of x, y to be the vector minus y, x. So point is taken to the vector minus y, x. So let's plot this by hand. Here I have the point, and here I have the vector that it's going into. So 0, 0 just goes to the vector 0, 0. And I'll sketch it as I go. I'm just picking points arbitrarily. That's going to 0, 1. So the vector from the point 1, 0 is the direction 0, 1 in length 1. Then 0, 1 is right here. That's going to go to minus 1, 0, the vector. So the vector minus 1, 0 goes this way, length 1. Let's try minus 1, 0 right here. That's going to go to 0, negative 1. And then finally, 0, -1 is going to go from 1, 0. So at 0, -1, the point, I get the vector 1, 0. All right, let's try 2, 0. That's going to 0, 2. So 2, 0. So 0, 2 goes like that. The length is 2 in that case. Let's try 1, 1. That goes to the vector -1, 1. So 1, 1 is right here. We go -1, 1. That vector goes like that. Then 2, 2 is taken to the vector -2, 2. So 2, 2 is right here. -2, 2 is going to be up here. Length square root of 8. So that this arrow, the last arrow I drew, should be longer. So it looks like it's kind of going around in a circle. And that's the case that each of these arrows is tangent to a circle centered at 0, 0. And if x is equal to x, y is the position vector of the point, with the terminal point xy, and f of x is minus yx, then if we dotted these, we get 0. So this says that the position vector and the tangent vector are orthogonal. That tells you that you're on a circle. Okay, then we can also talk about a gradient field. This is also called a conservative vector field. And that's if our function, our vector function is del f, that's the gradient of f, for some function f. And f is called the potential function for capital F. And recall what del f is. The gradient of f is fx, fy, fz, and that's a vector. Okay, I'll do some examples in the homework problems.